Well, good afternoon, everyone. My name is Nelson Moore. I'm here today with Dr. Mark Benson. He's the Director of Data Science at Frederick National Laboratory for Cancer Research, which is part of the National Cancer Institute. I'm really excited to be here for my first ever nodes. There's been so many great sessions so far today, and I'm grateful for the opportunity to speak with you all today. Today we'll be talking briefly about a process that we've developed to manage changes in Neo4j databases such as our Metamodel Database, or MDB, efficiently and transparently using a program called Liquibase. So as we go, please feel free to put any questions in the chat, and Mark will be there to answer those, and hopefully we'll have some time at the end to answer some as well. So first, I'll just give some quick background on the MDB and the Cancer Research Data Commons, or CRDC. So the NCI CRDC is a rapidly growing cloud-based data science infrastructure that connects cancer data sets of various types with analytics tools to drive scientific discovery for cancer research. And the data comes from diverse open sources such as genomic data from the Genomic Data Commons and canine cancer data from the integrated canine data commons. And all of these data commons have developed different data models to support their individual business processes, which is great, but it leads to issues with interoperability between them, which is really crucial for the researchers that need to have the ability to query across all of these various repositories. So the MDB was developed to help with these interoperability issues. And it's a property graph-based data model that records the structure of nodes, relationships, properties, permissible values, and data types that serve as the individual CRDC repositories models. It's also the local vocabulary of terms employed in the backend data system and terms from external sources such as ICD-10, SNOMED-CT, which are common healthcare coding systems. It has semantic mappings across the data models and terminologies. And the intention with MDB is to provide an up-to-date view across these data models for an integrated system of data repositories such as the CRDC. And some use cases for MDB include auditing and maintaining these data models as they are changed and updated, enabling transformation of data between different models via the stored semantic structures, and providing a single resource for viewing and evaluating existing data models in a system for model reuse or new model design. And to achieve these goals, the MDB needs to be flexible to allow for the updates and the storage of the latest decisions made by these CRDC stakeholders. And these decisions for any individual data commons regarding their data model are stored in something we call model description format. And that's just something that we use for each of these components to describe their data models. And on the right is an example from the Childhood Cancer Data Initiative. And it allows the SMEs that work with this data every day to make changes to their model in these YAML formatted files, which are validated and stored in GitHub repositories that we then use to update the MDB. And it breaks down their data model from a spreadsheet template with tabs and headers and sets of permissible values into a property graph representation that's human readable and computable and easy to translate to a Neo4j database. So what happens when these files are updated by an SME? Say if they add a new field or remove a redundant term from a value set. Well, when the CRDC changes by adding a new model or mapping or terminology or updating an existing one, then the MDB needs to reflect those changes so that it accurately represents the CRDC's current version of reality. It needs to do that in a standardized and auditable and reversible way so that errors can be caught quickly and the integrity of the MDB is maintained. So when we were exploring options to do this with the MDB, Mark found a tool called Liquibase, which is typically used for managing database schema changes, but we found that it met a lot of our needs as far as actually updating the data in the MDB in an auditable and a standardized way. So what is Liquibase? It is an open source application for tracking and managing and executing database changes that effectively provides us with a version control system for the MDB. And we run it from the command line. It works with many different databases, but most importantly has a Neo4j plugin that gets regular updates and attention from the excellent Florent Beville, who works for Neo4j. And changes to the database are stored in these changelog files, which are text-based files with a sequential list of changes to be made to the database. And these can be raw Cypher, SQL, or in XML, YAML, or JSON formats, and we use XML. And the best practice is to use Git or some type of version control to maintain these change logs. And they're made up of individual change sets, which are units of change that are tagged with an author and an ID, which are used to create a unique ID for each change set that's run. And change sets by default are run in a single transaction and either all succeed or all fail, but this behavior can be configured for your individual use case. And the best practice is to specify one change per change set, and the operation that's performed is called a change type, which specifies what the change does, and it corresponds to Cypher or SQL statements applied to the database. And the Cypher change type is primarily what we use, and that lets you just run custom Cypher statements, but there's other types supported by the Neo4j plugin that perform more specific tasks, such as insert and load data, node merge, and extract property, which extracts properties out into their own nodes. And other tags can be included in change sets to further configure the behavior, such as rollback, which are commands to undo changes made to the database. And you can undo a specific recently applied change or all changes back to a set point. And some change types have automatic rollback behavior, but you can also customize that behavior with any given Cypher query. Preconditions are the other tag that you can include, and those control execution of updates based on the state of the database. And those include version and addition, as well as Cypher check, which executes a Cypher query and checks that the return value matches what's expected. So does a change that we expect to create one node actually add one node to our total count? So that's just a really quick overview of some of the fundamental Liquibase concepts that give us change management capabilities and the ability to update the MDB. So now we need to actually build and populate our change logs and change sets with the actual changes that we want to make. So we do this programmatically in Python using a few packages that we've developed, which are all available and published on the Python package index. And Bento Meta is one of these that lets us provide object representations of property graph-based data models such as MDB in Python. And it's also the home for our scripts that generate these change logs with the custom Cypher queries that we use to make changes that we need to make in the database. Bento MDF package allows us to load and validate MDF files into Python, as well as find the difference between two MDF files. So this diff compares these two files and generates an output that highlights the differences between these two versions. And we use it to identify incremental changes in new versions of a data model, such as adding or removing a node or changing an attribute of a node. And these are used to generate a change log, which we use to update the data models in the MDB. And Liquichange is a package that we developed to support building Liquibase Changelogs in Python. So we knew we wanted to use Bento Meta and Bento MDF to generate a changelog based on a model or the difference between two models, but we couldn't really find a package to build changelogs in Python, only ones that kind of interacted with already existing changelogs. So we developed this Liquichange package, which supports features that I mentioned on the last slide, such as change sets, preconditions, rollback, while also encouraging some best practices, such as one change per change set and maintaining a consistent ID format for those change sets. So this is our workflow from before, and now with Python and Liquibase, we kind of have that missing piece. So our models, mappings, and terminologies are stored in these MDF files. Those are generated and updated by SMEs and used as the input to our Python scripts that build Liquibase Changelogs, which are then stored in the Bento MDB GitHub repo, which is our base repository for creating MDBs. It's the home for these changelogs, and it has documentation on setting up and updating a new MDB. And for us, we can set up an MDB with either all the latest models and mappings or terms, or since everything is kind of separated by model and the source of those files, then users can pick and choose specific versions of models and mappings and set up an MDB that's kind of tailored for their individual use case if they want to. So we then take these changelogs that are stored in Bento MDB and use the Liquibase update command to apply the changelog to our main MDB instance. So since everything's up on GitHub, it's easy to track changes and solicit feedback, but it also gives us the opportunity to integrate this workflow with our CI/CD process via GitHub Actions. So currently we're working on a GitHub action that would trigger when CRDC model repo has a new release and automatically run the diff script to generate a Liquibase changelog and use that to update our development branch with those changes, letting the SMEs, quickly view their new release in Neo4j. So just in a nutshell, Liquibase, free open source tool that can help you manage changes to Neo4j databases, such as Metamodel Database. These Liquibase changelogs provide documentation of changes and the ability to roll back to specific points in time, which effectively gives us version control for an MDB. And the Liquichange package offers a way to build Liquibase changelogs programmatically in Python while encouraging some Liquibase best practices. So this lets us generate and store the Cypher statements used to make changes to the database in a transparent and a reversible manner. So the end result is a Neo4j database in the MDB that brings together the latest versions of the many various cancer research data commons models and mappings. And I would like to just, take this opportunity to thank Neo4j staff for putting on this event. And I've learned a lot today, so I hope this session was informative for y'all. So you see our time here. If we have time for any questions, I think we have a couple minutes. So I'll stop yapping and see if we have any of those.